Welcome to Construction Genius. Today we have a fascinating discussion lined up with Anna Cheniuntai from Apis Cor, a company specializing in 3D printing technology for the construction industry. And Apis Cor have used their technology to build the world's largest 3D building, a 3D printed building rather, which is a 2-story office in Dubai that has a height of 9.5 meters and a floor area of 640 square meters. Pretty interesting stuff. So you might be rolling your eyes a little bit and like me saying, man, I've been hearing about 3D printing for ages and I'm not sure if it's ever going to take off. And we're going to delve into the current state of 3D printing, the challenges it faces, and its potential to revolutionize how we build. So let's get started. Hear from Anna about how Apis Cor is shaping the future of construction. This is Eric Anderton, and you're listening to Construction Genius, a leadership masterclass. Thomas Edison said that genius is 1% inspiration and 99% perspiration. If you're a construction leader, you know all about the perspiration, and this show is all about the 1% inspiration that you can add to your hard work to help you to improve your leadership. Anna, welcome to Construction Genius.
Hey, hello.
So great to have you on the show. Your company, Apis Cor, really specializes in 3D printing. Now, I've been hearing about 3D printing in construction for many, many years, and it seems like one of those pipe dream technologies that people talk about. There's some specific applications, but widespread adoption is something it's not arrived yet. So tell us where we are in the life cycle of the development of 3D printing technology for commercial contractors at the moment.
Oh yeah, absolutely. Happy to speak about that. Yeah, and I agree. It was like years of the technology in the construction and saying that we're going to save everything. And it's like a response to the housing crisis. But we actually don't say that. I don't believe that the just 3D printing by itself is the universal solution for everything that happens wrong with the construction today. I even have a TEDx talk about this, that it's not the answer for the housing crisis. However, it's really important puzzle, how to help building houses faster and more affordably. And honestly, like the reason why the construction 3D printing technology hasn't been really taken off yet, because all of the companies, they using the equipment that it's not scalable. So basically, the most popular type of equipment is the big gantry printers. This is what we see all around. And it's like people are so excited just to see the 3D printed layers. And like, this is the fancy technology that's going to save everything. But it's not. Especially that type of equipment, it's not scalable. You need to have a crane. You need to have 10 people just to assemble that big piece of equipment on site. And it's like sometimes you need to have like a 2 semi-truck to transport the pieces of that big type of equipment. It can cost up to $40,000 just to deploy that piece of equipment. And people just try to not to bring that cost, just deployment cost. And this is the huge mistake. They just publicize the new way of building houses, but what the actual cost? And I want to make it really clear that we don't use gantry printers. We actually solve all of these problems. And this is not the way how it's going to scale. So this is why we created completely different type of equipment, fully proprietary, built from scratch, never existed before. And you can see, maybe if you saw some of the videos, how mobile it is. Yeah. Just one person to operate it. And we literally have zero cost to deploy the machinery. You need the pickup truck, trailer, and one person with a joystick to deploy the equipment on the slab and start printing. So we just really realized that if you want to do the disruption, we need to completely rethink what's been done before with the 3D printing in construction and create really specialized equipment. So this is where our company headed right now. And for us, it's just really how soon we can build more manufacture more machines. We are really on the verge of this process right now. And creating the technology from scratch, it's not really easy. So for us, it took like 5 years. We 3D printed a lot of buildings when we actually tested the technology. And the goal was not just to create a PR, say like, we're saving the world, but actually really thoroughly test the technology that we were creating and figure out what the best product, how it's going to look like for the home builders and contractors can successfully use it.
Okay. Now, so let's talk about that a little bit, because again, you use the dreaded words for commercial contractors, tiny homes, right? And I know that my audience is not that interested in tiny homes at all. So talk about the viable applications of 3D printing for commercial contractors. For instance, you have on your website the example of a 6,900 square foot two-story building in
Dubai.
Dubai, yeah. So now, is that something that you guys did, or is that something that has been done?
Oh, no, this is our company done. You're on our website. Yeah.
Yes. Now, okay. So now tell me about that project specifically, please.
Oh, yeah. This is really a unique project because first, that was like 4 or 5 years ago. And that's still official Guinness World Record as the largest building ever printed so far. That's a 31 feet tall building, two-story, and 6,400 square feet of living area.
Right.
And just single printer was used to do that. If I had the pictures to show you, you would see that our printer is so tiny compared to the building envelope. However, because the machinery that we use is so mobile, we just moved the robot like a 10 or 11 times to cover that such a big printing area. And again, this is the feature that only our technology can provide today. If you use like a big gantry printers, you would need to build gantry printer that would be bigger than the building, right? It's like bigger than this giant building. That would be just impossible to print. It just would be the structure of that type of printer would cost maybe like $10 million. I don't know. So we didn't have this problem because we have the different robotic solution.
Yeah, this is interesting here. So if you're on YouTube, you can check this out. If you're listening to the audio, go to the YouTube video and you can check that out. But I'll just start playing this video here.
Yeah, and this video is actually showing the mobility of the equipment in the best way. Because you see that Frank, our robot, is basically kind of like a little tank on a Caterpillar platform. And you 3D print the wall. And once the job is done, Frank can leave the job site just through the doors. You don't need to use the crane or pallet jack or something like that. It's just that easy to deploy and then wrap up the work and be good for the next construction site.
Okay. Where do you see 3D printing, let's say in 5 to 10 years' time, in terms of its commercial application?
Well, I can also speak about our technology and where we see the application for us. So for us, it's the low-rising houses, of course, up to 3 floors. This is what our technology is well suited right now to as an application. But it also can be low-rising commercial structures, right? In addition to that, because the printer that we invented, it's so agile and so mobile, and you can actually print big structures like we already proved by building in Dubai. We can also take applications like tilt walls, for example. Tilt walls, it's something that built for the real construction building, for the commercial application. And we can 3D print those walls directly on site. We can save money on the transportation. We can save money on labor and the form work that we typically use when you cast the tilt walls on site. And we can 3D print walls 32 feet tall. Typically, tilt walls, they are about 39 feet tall, but we also can do this because here you see the printer. This is the black arm. That's relatively very small compared to the house that we printed. So tilt walls, also seawall. Seawalls, it's, to reinforce coastal area. And it's getting very concerning right now because of the sea level rise. In the next 10 years, the United States is going to spend about $400 billion just to reinforce the coastal area. Otherwise, all of the buildings are going to be, under the sea. So we also can do this. We can 3D print the seawalls directly on site. Noise barrier walls, for example, we also can do this. And again, I don't see that the other companies like gantry printers, other companies who uses the different solutions like gantry printers, I don't believe it's possible for them to do, again, due to the design of their robot. But for us, we already, demonstrated that similar application can be successfully done by our. And here in the video, you see how Frank and Gary basically feed the trailer. Yeah.
Yep. So slow down a minute, Anna. Tell us Frank and Gary again, because you're going to be we're a little confused here at the moment. Who's Frank? Who's Gary?
Frank and Gary is our equipment. Frank is the printer, and Gary is the mixer.
If you're listening to the episode, please go to the YouTube and you can see the video of what we're talking about here. It's pretty interesting.
Yeah. So now it's Gary, the mixer and pump machine, rolling out of the trailer. So we name all of the robots that we created. And now it's Frank coming out of the trailer as well. And you can see that the operator, he's just using the laptop or like a small notepad to remotely control and move the robot. Yeah, and this is basically it. Then you're ready to start printing the walls. So this is really something that no any other company has or even started to think about the same approach. The mobility is really important. So here you see Frank and Gary on the flap.
Yep.
And now we're actually preparing to install the capsules for the vertical reinforcement.
Okay. That's interesting. And so how long does it take for one of these smaller buildings to print?
So this building that you see now, it's our residential house we just completed in Florida. It's 5 minutes away from our headquarters. That was 4-bedroom, 4-bathroom building. 2,100 square feet house, pretty big house. It took for us about 60 hours of machine time to print. Yep. And normally it would be spread within like 1 week. Because typically you can work like 8 hours per day. Sometimes you're just not allowed to do construction work after 9 p.m.
Sure.
So it's really like conservatively speaking, it's 5 to 7 days to 3D print the walls for the residential house. Like let's say like a standard 2,300 square feet building.
And what are the cost savings for a 3D printer versus just the traditional way of doing the construction?
We right now estimating that it's going to be up to 20% cost saving, but it really depends on the design, really depends on the location, and it really depends on what type of finishing you use. So the maximum cost savings can be done if you just 3D print the walls and just paint them. Because you can actually save about $9,000 just on stucco. Because we 3D print walls with a very smooth surface. We don't have this like a big foliages, like a big layers. We don't have that. We have the mechanism that smooth out the walls as we print. And it's like a very smooth surface, and we can just paint it right away. And saving costs on stucco is very important because, especially in Florida, stucco typically is not installed properly. So then it's all of the cracks starting and you need to repair this. But anyway, even if we don't install stucco, it's already like $9,000 of cost savings per house. And then we also can expedite the process how we install mechanical, electrical, plumbing, even like a drywall, and the reinforcement as well. So again, like it really depends on what you build, where you build. It can be 5% savings, or it can be up to 20% savings.
Hey, I hope you're enjoying my interview with Anna today. Quick plug for my book. Ooh, look at it. It's real close to the camera if you're on YouTube. Construction Genius, effective, hands-on, practical, simple, no BS, leadership, strategy, and sales advice for construction companies. Let me encourage you. Go out to Amazon right now and purchase a copy for you and 10 of your leaders. So 10 total copies. It'll cost you less than $200. And then send me an email saying, Eric, I purchased 10 copies. What we'll do then is we will book in an hour with me to do a question and answers on the book and an additional bonus training session for your leadership team. I would normally charge $3,500 for a session like this, and you get it for under $200. That's what you call a killer deal. So go out to Amazon, buy the books, email me, eric@constructiongenius.com. We'll set up that time, and it will be something that will tremendously benefit your business. Okay, let's get back to our conversation. So one of the concerns that people have about 3D printing is like you can tell a building is 3D printed from a mile away, right? Because of the aesthetic of it, or at least that's one of the hits on it. So, if someone wants to adopt 3D printing, is it Is it a strategy that they can adopt and still achieve the aesthetics that the clients are looking for? Or is that one of those limitations that's not going to be overcome?
So that's the problem, because a lot of ugly houses been printed.
Yeah, right.
Honestly.
Yeah.
This is really the problem. So if you drive by our house that's just shown in the video, you
Yeah.
wouldn't tell that it's printed. Because again, like we have completely different type of surface and quality of the walls. And
Right.
that's something that we also we need to really figure out how to build really nice houses, how to 3D print really nice houses.
Mm-hmm.
Because like a big ugly layers, you need to smooth them out, you need to apply some finishing, and you actually create more cost if
Yep.
your printing quality is not good. So yeah, you definitely need to stop by our house in Melbourne on Space Coast in Florida. And also what we realized that we can't really leave the 3D printed walls for the interior design. It's
Yes.
still better to have the drywall. Even
Yes.
I wouldn't really live in a 3D printed house without the drywall. I mean, if it's kind of like a modern type of design, that's fine.
Right.
And maybe somehow mix it with some sort of like a finishes. But if you just want to have the house and you want to live in that, I would like to have the drywall. So we recently figured the new wall design, and this new wall design, it's kind of like a composite wall. It's already integrated with the drywall, and it does not add more cost. So
Okay.
I don't want to tell all of the boring
No.
technical details, but
Yeah,
we
yeah, yeah.
figured this out too. Yeah, but I agree, it has to be very nice inside. For the
So then,
exterior, we figured the finishing. Yeah.
who should be buying this from you? Should it be a GC? Should it be a concrete contractor? Who's your target audience?
So, we have a lot of different type of customers, but it's construction companies, some of them general contractors, some of them those who just build in walls with the concrete block,
Uh-huh.
and they want to expand, and they're going to use our technology as a tool to 3D print the wall. We as a company, we really position ourselves as a technology provider for businesses. Like if we are in the B2B
Yep.
industry, we don't really go and build like the houses for end users. We're not the construction company.
No, I understand that. Yeah.
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 Yeah. So then your target audience would be GCs, but then also are subs interested in what it is that you offer?
Yes. For example, some of the national home builders, they work with the subcontractors that also huge. They operate in every state.
Yep.
So they already have labor, and they already provide the materials to build the shelf, for example, for the national home builders and any other home builders.
Yep.
So we also in very good conversations with this type of subcontractors as well, because for them, it's the tool how to expand business, right? Because the labor issue is getting worse and worse, material shortages, even like the concrete block shortages as well. So they see this as an opportunity to de-risk and also expand. They're still going to build houses with the concrete block, but they also can integrate and start using 3D printing technology. And then instead of, let's say, 100 houses a year, they can start build 200 houses a year right now. So this is really important for the customers who are going to use the technology.
What's the biggest challenge that the 3D printing technology has in terms of integrating with MEP trades, with the mechanical, electrical, and the plumbing?
Well, I wouldn't say it's like a really challenge. For some reason, everybody thinks that it's such a big problem to install mechanical, electrical, and plumbing. We kind of have different experience because our walls, the walls that we print, they structurally the same as concrete block wall. We purposely did that. That simplifies the permitting process, engineering, and this is how you sure that your house is safe and sound, because it's reinforced the same way and everything done the same way. So we installed the mechanical, electrical, and plumbing also the same way. But with the new composite wall, it's going to be even more easier. So we're going to share more details about that on our next project that we're going to do early next year.
Uh-huh.
But this is where we're going to demonstrate that actually we figured how to even expedite this process. And sometimes you can do this in the same time. So for example, you 3D printed the first section of the house, and then you move to the next section to 3D print the next section. And your subcontractor can already start working on installing mechanical, electrical, and plumbing on the first section. So like doing some of the work simultaneously, it's also something that on the horizon to bring productivity up.
Where do you see the greatest potential for growth in the use of 3D printed buildings in construction?
I really believe it's for the single family houses, because
Yep.
this is something, especially in the United States, the situation is really bad. So everybody
Yep.
wants to have a house. Younger generation can't afford it. So I believe that if we can increase supply of houses, supply and demand will meet each other, and the prices will naturally go down. So we truly believe that it's like the massive market of single family houses is a real like the something that we need to address as soon as possible.
Now, we talked a little bit about integrating the 3D printing technology with traditional construction practices. What do you find is the biggest obstacle when you're going out to your customers? Why they're saying, Anna, I like the technology, the videos are cool, but it's not a fit for us. Why are they saying that? Why aren't they just embracing it and taking it on?
Well, we didn't hear something like that,
Okay.
actually. So typically we have companies who say like, we need this solution yesterday.
Right.
I have 100 houses to print. I need the printer right now. And like,
Right.
we spend in our manufacturer, we just really like it, not in the capacity right now. But sometimes, so what I see kind of like the hesitation, and it's
Yep.
like a very fair hesitation, how to train personnel to use this new technology,
Okay.
right? So they're like, okay, we have this great piece of equipment, but who's going to operate it? We also spend a lot of time to make the technology very easy to operate by any, level of skilled people.
Right.
Even like 5 years ago, we participated and we won a NASA competition. And the idea of NASA competition was how to 3D print shelters fully autonomously, meaning that it's not going to be any human intervention during the
Yes.
process.
Yes.
It was very challenging. We actually had 5 hours of continuous printing with like a 20 minutes total human intervention.
Right.
And that actually made us think that, this need of that printing autonomously, it's not something that only needed for Moon and Mars. It actually needed here today on Earth,
Right.
because we need to reduce the bar of who is actually able to operate it.
Right.
So right now we need one person to do this. And we even can have the teleoperation. 2 weeks ago, we had a teleoperation of the printing process, meaning that our printer operator, he was in California. We were doing printing in Florida. He just logged in, into the system. And because we have all of the sensors and all of the data that shows you live what happens with the equipment, he was able to operate it. Of course, we also have cameras. You can see how the printing process is going. But more importantly, you see the pressure, for example, you see the speed, you see all of the system, kind of like the you in the airplane, you see all of the performances and all of the detail. So we're working on that as well. And we have Apis Cor University. We have online courses educating people about the technology in general. We also going to release soon online course how to build 3D print the house from A to Z using our equipment. And we already have 600 people who signed up and completed our online courses for the past 3 years. So this is something that we also started working from day one to help home builders to be more confident, that okay, it's not the technology from alien. Actually, everyone can use it. Yeah. But I would say this is one of the big hesitations.
Is that also one of the objections to adopting 3D printing is because it eliminates labor? So like if you're working with a company that has union relationships, they're more reluctant to take on the 3D printing?
That's completely wrong perception. It's like, I understand. It's like when you see the robot doing the job that you could do, you automatically you're scared of this and say like, oh my God, the job's going to be taken. But in construction, the situation is really bad today, even with the, human work.
Yeah.
So that's in next 10 years, about 41% of the current workforce is going to be retired.
Yes.
And it's current workers are getting retired in a record numbers, and the younger generation like me, for example, and even they're younger than myself.
Yep.
We have zero interest in doing a hard physical dirty work on site mixing the concrete.
Yep.
So the problem is actually that skilled labor is going to be very hard and expensive to find. So it's not something that we take in someone's jobs. It's already the problem to find people to do the job.
Yeah.
So what we do with the robots and technology is we fill in the gap, for this labor shortage. And it's still so much work in the construction. that
Yep.
it's still enough for people and for the robot. So it's not really like that. And it actually, because we have the robot that, as I already mentioned, it's teleoperation, we even open the opportunities for more people to work, right? You can work from home and operate the robot remotely. Let's
Yeah.
say robot somewhere like in the remote area, and you just sit in that home and operating this. It's actually open opportunities for people who wouldn't be able to go on the construction site and the construction environment because it's dangerous and like a physically demanding job. But now it's like a different type of construction workers, right?
It's interesting. You think about how you could let's say a builder that does homes for ones and twos. If they purchased one of these, they could go into remote sites for like high-end clients and print, let's say, an ADU or something like that for them in a remote location, and then not even have to send people out there to do it, but have them do it remotely.
Yeah, that's the future. This is the future that we want to achieve. That would be really exciting. Not even like if ADU, let's say it's really remote area after some disaster, for example, it's really dangerous for people to come there, or even like hard to get people there. So that's really something that's really exciting about this technology, especially like the solution that we build in.
What do you think then is going to be the main obstacle to more widespread adoption of 3D printing?
So I think it's just really to ramp up the production of more robots to be on site.
Yeah.
And then really like train people quick enough so the robots can consistently go and print everything. And of course, like a consistent technical support in the beginning, especially. I think it's just gonna take some time. Yeah.
Where do you guys do your manufacturing?
We have headquartered in Melbourne, Florida.
Yep.
It's Space Coast. We're going to open another one in Bay Area in the Silicon Valley.
Oh, cool.
Yeah.
And so where do you actually do the manufacturing?
So we not really do like a large scale manufacturing yet.
Right.
We're ramping up right now.
Sure.
And we also have subcontractors who doing the sub-assembly.
I see.
And we're going to add more like the final assembly company. So the plan is to keep doing this in Florida and maybe later open more like a large scale production somewhere in Nevada or Arizona.
Okay, so right now you're kind of subbing out the manufacturing and putting the finishing touches on. So you see yourselves more as a technology company as opposed to the manufacturer. Is that how you guys are viewing yourselves?
Actually, no. We are like we like a caterpillar. Actually,
okay, a caterpillar. Okay,
Yeah.
okay.
Yeah, and we supply the 3D printers, right? The hardware and also 3D print material.
Yeah.
Because 3D print material also has to be specialized blend. You can't really go and use ready-mix concrete in just a puddle. You will need to be able to form the layers. So we also supply the materials. It's part of the technology because our goal is to help home builders just consistently and quickly print houses with the consistent quality. And 3D print material is the important part of it.
So then how can you ensure as you grow the consistency of the material quality in different regions? Because, obviously, everyone has problems with different quality cement, and different materials in different areas of the country. How do you plan to handle that?
Yeah, so, we don't really need to invent the wheel in this part of the work, actually.
Yeah.
Because the material that we use, it's a dry mortar. And dry mortars, they have been existing for like years. It's very well known and established industry how to produce dry mortars. Something like a plastering, for example, or grouting, something that you go to Home Depot and you purchase the 50-pound bag of grout, for example, or plaster. So our material is basically like the same in terms of the physical properties. And we can produce it in the same type of batch factories, right? And it's only like how you install your quality controls and procedures to produce this material. And it's also already been existent for the dry mortars, for like a plastering, for example. You just, before you produce something, you do the quality controls, you make sure that the cement is meeting the requirements for this particular formula. So that's easier than expand the manufacturing for more printers. Gary and Frank, supply them like 1,000 within the next 5 years or something.
That's great. So tell us a little bit more about how we can find out more about your company. I know for those on YouTube, we saw a little bit about your website, but give us your website, tell us more about it and how people can get in touch with you.
Oh, yeah, absolutely. Our website is the great place to learn more about us. www.apis, is a pineapple is-cor.com. But you can actually just Google us, Apis Cor, and you will see the website. We're also doing the crowdfunding, fundraising right now on Start Engine. But just also find us on the social media. We post a lot of really valuable content because we try to educate our audience and customers and whoever interested in this technology how to actually use it. So we generate a lot of educational content. But if you just Google us, you definitely will find us.
Great. And we'll put the links in the show notes to the website so that you can check it all out.
Yep.
Anna, I really appreciate your time. Let me ask you this. In 10 years' time, where is your company going to be?
Well, we want to produce at least 1,000 houses. 1,000 printers, and consistently have them in operation. And, we just really here to build a great company that's going to last for hundreds of years. And we believe that what we do with our technology is we changing how the house is going to be built for the next millennia, right? So this is basically our vision.
Excellent. Well, I appreciate you joining us, Anna, and I do wish you all the best.
Yeah, thank you so much. That was a pleasure.
Hey, thank you for joining us on today's episode of Construction Genius. I hope you found our discussion on 3D printing as enlightening as I did. And if you want to learn more about Apis Cor and their innovative technology, be sure to visit their website and follow them on social media. Links are in the show notes. As always, remember to subscribe, leave a review, and share this podcast with others in the industry. And we will catch you on the next episode.